Let's do surface tension. Are we there? Surface tension is simply the force. Definition, please. Surface tension is simply the force. Surface tension is simply the force that acts that acts at the surface of a liquid. Surface tension is simply the force that what acts at the surface of a liquid, making it to behave like an elastic, stretched skin, skin, elastic stretched skin, skin, elastic stretched skin, skin. Are you there? So look up, please. Look up. Surface tension is the force that acts what at the surface of what a liquid, abi, yes, or fluid, if you want to, making it to behave like what an elastic stretched what there. Hold on. Look up. Let's say I have a tap this way. Right? Let's say I have a tap this way. Right? And I have my bucket this way. Are we there? Observe that after fetching water finish and you close the tap, there will be a little water, droplet of water there at the tip. It will not fall. Right? So it will now become, that water now become bigger and bigger and bigger until what? It now falls into the bucket, abi? Now, here's the question. What was keeping the water from not falling initially to the bucket before? It was what? The surface tension what? Force. So the power, the weight of the water then was lesser. Yes. So surface tension can what? Carry it, abi? But in this case, it's not bigger than what? Surface tension force. So it's now what there? It's now drop. That's surface tension. Also, to stress surface tension, there are some ants that walk on water. Do you know that? Some ants walk on water. What do they call it? They call it era. What do they call it in English? So someone do walk on water, abi? Why is that ants drink the water? Because what? Surface tension force can hold it. That's why it's not what entering. That's your what then? Surface tension. This is your what? Your science definition. Let's look at scientific definition. So by the place, coefficient of surface tension. Coefficient of surface tension. Let's do coefficient of surface tension. Are we here? This is the ratio of the force acting per unit length of a fluid. This is the ratio of the force acting per unit length of a fluid. Per unit length. Per unit length of a fluid. Are we there? It is represented by gamma. It's represented by what? Gamma. This gamma, are we there? Yeah. It's like Y, but not that just this gamma. Right? Gamma. So note that surface tension is what? Gamma. Viscosity is what? Eta. I showed you, madam, last class. Eta, viscosity. Right? So note that surface tension is what? Gamma. Viscosity is what? Eta. But forgo this one for now. Let's go on gamma, please. So look up. Mathematically, I am saying that gamma, or perhaps surface tension, is what? Ratio of what? Force over what? Over length, please. Are you there? Force is written in what? In Newton. Length in what? In meters. Are you there? So hence the SI unit for what? Surface tension is what? Newton per meter. Very important, please. So note that the SI for surface tension is what? Newton per meter. Now look up. Let's do some derivation. Gamma is equal to what? Force over length, abi? Call this man equation 1. Are we there? Multiply, make force subject. I'll have that over 1 here, abi? 4 times 1 is what? Force equal to what?
Gamma over length.
No, gamma times length, abi? Let me call it L gamma. Are we there? Call it what? L gamma, abi? Now look up anything. Call this one what? Equation what? Equation 2. Are we there? Water, because I'm doing free, abi? Live water, abi? Water in 3D is what? Spherical in nature. Look up this water, abi? Water, I want to explain something, please, before I proceed. Water in 3D is spherical in nature. Water in 2D is what? Circular in nature. Are you there? So now I'm seeing length here. I'll now use what? Length of a what? Of a circle. That becomes what? The perimeter of a what? A circle. I went from saying that the shape of a water in 2D is what? Circular. If it's circular, I'll use the what? The circular circle. No, the perimeter of a circle. So now I'll now say L equal to what? 2 pi r. From where? The perimeter
Of the circle.
Sorry, perimeter of what? A circle, right? Now look up. I'll now put this one here. Call this one, call it equation
Theory.
equation 3. Call it what? Equation what? 3, abi? I'll now say put 3 into what? Into 2, right? What's your 2? F equal to what? What's your L now? 2 pi r, abi? So I have gamma into what? 2 pi r. Combine what I have there. F is equal to what? Let number come first. That becomes 2 pi r gamma. Call this what? Equation what? Equation 4. Are we there? Are we here? Alright, at this point now, at this junction, I'll recall from weight. What's weight? As we know, W is what? Mass times what? Gravity. From that friction we did earlier now. We said R equal to what? W. Mass and gravity. So look up. Now, also, with respect to density, density is rho, abi? Is what? Mass over volume. Abi? Make mass subject. I'll have that mass is what? Rho V. Call this what? Equation what?
5.
Equation what? 5. Are we there? Equation 5. Are we together? Call this equation 5. Equation what? Equation 6. I should have given the formula, but here you do the derivation. You do the variation here. Don't just know how formula comes about. Know how you derive them. Right? So now look up, please. Call equation 5 and equation 6, abi? I'll now put what? 6 into what? Into 5. Anyway, I see M, I'll put what? Rho V inside here. So I'll now say put 6 into what? 5. What do I have there? W, weight, is equal to what? Mass. What's your mass? Rho V. Rho V, abi? Then what? Your gravity. Are we there? Hold on. I'm saying volume, abi? This is what? Volume, abi? Abi? So, but volume is what? Area times height. Why is it so? I explained in last class. When I doing discharge, I explained volume has been area times height. You know what I'm saying? Volume is what? Meter what? Cube, abi? So I say this can become meter square times what? Meter is meter cube. Meter square is what? Area. Meter is what? Height. So I get this formula from what? SI unit. So volume is what? Area times what? Height. Usually volume is length times width times height. But in terms of SI unit, I can get what? Area times what? Height. So call this equation what? 7, abi? So put 7 into what? Into 6. So put 7 into 6. What do we get there? What's 7? So that becomes what there? M equal to what? Rho into what's your V? That's what? A H. Are we there? Are we here? Call this man equation what? Equation 8. In science, you do the derivation. Equation 10, 15. You have equation 10, 15. bottle full. Yes, we equation A B. Hold on, let's proceed. I don't know this one on hand too. Should we proceed? All right, from here now. Look up from here. Now look up from here now. Per se. Hold on. We are to put, observe what we are to put V into what? Equation what? This equation now. This equation. Yeah. Because the what I'm looking for, no mass. Right? No mass now. So I'm going to have what? W Abi equal to what? Rho what's not sorry? Rho what's your V now? AH Abi. Then what? Your G this way. Call this one equation what? Equation what? 8 Abi. Now this A is the area Abi. Now since I'm using perimeter of a circle, I'll not use what there? Area of a what? Circle. So A is what? Pi r squared. That is what? Area of a circle in what? In 2D. I explain this, right? I explain why it is 2 pi r. I explain why it is what? Pi r squared. Now I'll put this one into what? Equation A B. So I'll have what? W as equal to what? Rho into what your A? Pi r squared, then H, then G. Are we there? Combine what I have there. W is what to what? Pi r square rho G H. The same thing. Now hold on. From equation 4, I'm seeing force. Let me call equation what? Equation what? 9. I'm seeing weight. Force and weight are what? Are having the same S sign in it. Newton. Because of that, I'll now what? Equate the two of them. What's your force here? That's 2 pi r gamma. What's your weight here? Pi r square rho G H. In math, if I have something, the same thing at two sides. So this one cancel this, right? Cancel one of it here. I have what? 1 left. So I have what? 2 gamma equal to what? R rho G H. Abi? Yes. I want to make it subject. What do I do there? Divide by what? R rho G. This cancel this. Hence, I'll be having that H is what? 2 gamma over what? R rho what? Rho G. This formula I am looking for. So this H is called the height of fluid in a test tube. So this is the formula I'm looking for. Please copy down, please. Copy down. Formula I'm looking for, please. So note this, please. Note that given angle of contact H equal to what? 2 gamma over R rho G cos theta. So if I'm giving angle in the question, I'll use what? This one. If I'm giving angle, I'll use what? I'll just use this one, the plain one. So if angle is given a question there, use what? Cos theta. If angle is not given, directly this way. So let's do one past question on our hub, please. Let's do one question on our hub, please. I said given angle of contact, use cos theta. Just attach it to it. This is a given angle. Just attach to it, please. Example, please put down. When a capillary tube is depressed in a vessel of water. When a capillary tube is depressed in a what? In a vessel of water, comma, The water rises 5.75 millimeter beyond the surface tension, beyond the surface per se, please, beyond the surface of the water in the vessel, beyond the surface of the water in the vessel. Full stop. Are we there? The same tube is depressed into a similar vessel. The same tube is depressed into a similar vessel. The same tube is depressed into a similar vessel of mercury. Are we there? Comma. The mercury is depressed below. The mercury is depressed below. Are we there? The outside level. The outside level of the mercury in the vessel. Below the outside level of the mercury in the vessel. Below the outside level of the mercury in the vessel. Full stop, please. If the variation H, small h, please, small h. If the variation H in the level of mercury is, if the variation H in the level of mercury is 0.2 centimeter, is 0.2 centimeter, comma. Are you there? Calculate the surface tension of the mercury. Calculate the surface tension of the mercury. Handwriting has changed. Calculate the surface tension of what? Of mercury. Assume the surface tension of water to be, are we there? 7.5 times 10 to the power minus 4. 7.5 times 10 to the power minus 4. 10 to the power minus 4. This way. Newton per meter. 7.5 times 10 to the power minus 4 Newton per meter. Are we there? Comma. Angle of contact of mercury. Angle of contact of mercury. Are we there? Glass. Mercury glass. Angle of contact of mercury glass to be 130 degrees. 130 degrees. Are we there? Comma. Density of water and mercury to be, densities of water and mercury to be, density of water and mercury to be this one and this, please. Densities of water and mercury to be this and this, please. This and this. Are we there? Respectively, take G. Take G as what? 9.81 meter per what? Second square. Let's get it done, please. Let's solve this question, please. In the question so far, I know two things. That thing contain what? Water and what? Mercury. Are you there? Water and what? Mercury. Abi? Let me do a quick analysis before I start solving. Look up. We know that we have that H is what? 2 gamma over what? R rho what? Rho G. True? Look up. True?
Yes.
Let's say this is for water, right? For what next? Mercury, right? Which is what? 2 gamma over what? R rho what? Rho G. Now look up. The same formula work with it, Abi. In that question, I'm having two sections there. Water and what? Mercury. Right? There was a tube. Look up. There was a tube like this. In that tube, they pour water inside. Let's say water is here. The height of water is here. That same tube now pour mercury inside. And now water and mercury can never meet. It's like putting water and kerosene. They never mix up. They always separate. So let's say mercury and water now are not mixing up together. So that same mercury and water are put in the same what? Test tube. Are you there? So look, where's the thing? Let's focus on water alone. Abi? Let's focus on water alone. Before I proceed with this, let's look at the givens. What are we given? Givens first. It says that I'm coming, hold on. When a vessel tube is depressed in a vessel of water, the water rises to out of what? So H of H2O. H is what? Water, Abi? So height of water, so abbreviation is what there? 5.75 millimeter. Please, are you there? Beyond the surface tension water in this vessel, the same tube. Listen up, oh. The same tube is depressed into a similar vessel of mercury. Abi? The mercury is depressed below, negative below. Are you there? Below the what? Outside level of mercury in the vessel. If the variation H, that is what? Height of mercury. So H, what's your symbol of mercury? That's what? Hg.
Yes.
Hg is mercury. So height of mercury is what? Is 0.2 what? Centimeter. Are we there? But what? It's what? A negative what? Is 0.2 because I mean what? Depressed. Are you there? Yes, downwards. That's the concept. Downward. Yes. So wait a second. All right. So it's depressed, right? So that's 0.2. And that says calculate the surface tension of what? Of mercury. Abi? So I'm looking for what? Gamma what? Hg. Right? Surface tension of what? Mercury. Right? And they give us what? Surface tension of what? Of water, Abi? Yeah. So gamma of what? H2O is what there? 7.5. That's about what? -4 per se. Newton per what? Per meter. It now says angle of contact of mercury. I'm given angle of what? Mercury. Abi? What's the angle here? 130 what there? Degrees. It now says again density of water and what mercury is given, Abi? Density of water H2O is what? 10 to power 3, Abi? Kilogram per meter, right? Density of mercury is what? It's given as what? 13.6 kilogram per what? Meter cube. I have Abi? So if G is what? 9.81. All right, sorry. 10 to power what there? 3, Abi?
Kilogram.
Hold on. 10 to power just okay 3 kilogram per what? Meter cube. So I have this. Given G as what? 9.81. So hold on. Look up. In this scenario here, we have two stuff: water and what? Mercury. If I want to get things right, look up. Let's say for water now. Focus on water. Am I given height of water? Check.
Yes.
Yes, Abi? Am I given gamma of water? Check.
Yes.
Is it even?
Yes.
Am I given radius of water?
No.
No, Abi?
Yes.
Hold on. I'm not given this yet. Am I given density of water?
Yes.
And gravity?
Yeah.
Yes. So I can look for what? R first. Look up. What do I have to look for? Find what? Mercury or air? Surface tension of what? Mercury. Surface tension of what? Mercury. Now look up. To find this one of mercury, I need to know what? H. Is H of mercury given?
Yeah.
H of mercury, is it given?
Yeah.
See it up for H of mercury.
Yes.
Abi?
Yes.
Is given Abi?
Yes.
Is given Abi?
Yes.
Is gravity given? Yes.
Yeah.
Next of mercury call.
Yeah.
But I don't know radius too.
No.
I don't know mercury too.
No.
Under mercury, I don't know two things.
Yeah.
Under water, I don't know just one thing.
Yeah.
Now, mind you, this tube have the same what? Diameter, Abi?
Yes.
So it means that the radius of water
It's the same thing.
as what? Radius of what? Mercury. So they get this one. I'll not put the value here to get what? To get mercury. That's the concept. What for analysis?
Yes.
So let's start for water. For water, what's the formula there? H of H2O, Abi. What? 2